Systems of linear equations. We're going to first revisit some stuff from Algebra 1, right? Where you solve these things using, you had three methods that you learned in Algebra 1 for solving systems of linear equations. Oh yeah. You solved them by graphing. You found the intersection of two linear equations, right? Two graphs of linear equations. That was the solution. You also used the elimination method where you would add and subtract the two equations from each other. And then you use substitution method where you would isolate one variable and then substitute it in. You guys should be good at substitution method just because of the way that I taught you how to do those distance problems, those rate problems. We're essentially solving a system of equations. So because we did it that way, we'll probably be a little bit ahead of the curve. And I'm going to also show you, as I said, the ultra cheater way to do this. Your calculator will solve these for you very quickly. We'll do it, okay? Ready? So the first thing is, you did learn elimination method, right? So in the past, you would subtract these, right? So 2x minus 2x is 0, 3y minus y is 2y, and 7 minus 3 is 4. So then you got that y was equal to 2 when you divided both sides by 2. Then you went ahead and you took this equation and you would say, hey, 2x plus 3, and you would substitute 2 in for y equals 7. And you would get 2x plus 6 equals 7. So 2x is equal to 1 when you subtract 6 from both sides. So x is going to be 1/2. Then you found that your solution was the ordered pair, or the point on a graph, right? 1/2, 2. And that's how you solved it, right? Well, it turns out that you can do the same thing using your handy-dandy calculator. So let's go ahead and do that. All right, so we can solve this in our calculator by using our matrix function. So that's going to be second x inverse. So you can see it right here, second matrix. Alright, and so for matrix A, I've got to go ahead and make it a 2 by 3 matrix. So 2 refers to our number of rows, 3 refers to our number of columns. And then in there, I'm going to put the coefficients of x. So these are going to be all of my coefficients of x. These will all be my coefficients of y. And this is everything that is to the right of my equal sign, right? So this corresponds with, right, 2x plus 3y equals 7, and 2x plus y equals 3, right? If we're going to actually draw the matrix for this, it would look like 2, 3, 2, 1, 7, 3. So that line is pretty much an equal sign in there. So let's go ahead, now that we have our matrices set up, you'll go in there and enter those things. So I just want to show you real quick. So if you go to that cell, you'll hit 2. And then you'll have to hit enter in order for it to go through, right? You hit 3, enter. That's how I got all of those numbers in there. So now that we have our matrix edited, we're going to go through and actually get an answer. So we go second matrix. We have to go to math, and all the way at the bottom, I'm going to scroll up to get to it. We have RREF. What RREF stands for is reduced row echelon form. They actually have, there's actually a whole college class where they do all kinds of crazy stuff with matrices. It's actually really important. So reduced row echelon form, we're going to put it in there, we're going to hit enter. I am not sure, okay, we're just going to, so I can't just put A here, right? I'm going to have to go second matrix, and I'm going to have to actually put in, matrix A. So let's highlight it, I'm going to hit enter, I'm going to close my parenthesis, hit enter. And get some weird error. What the heck? Okay, let's try this again. Second matrix. I think it's because I was in the wrong place. So I'm going to go math. I want reduced row echelon form of second matrix, matrix A. And there it is. I'm not sure why I came up with an error before. But here it is. Remember, we determined that our solutions were x equals 1/2, right? Because this is x, this one is y. So what this actually says is this says x equals 0.5 and y equals 2. That's what that says. That's how you read that. You see it? If this whole column here, this whole column is x, and this whole column is y, then this says 1y equals 0.5 and 1x equals 0.2. Cool? So that's how to do it with your calculator. Let's try it again. So let's try that again with the second example in lesson 30 over here. Let's do it. So in this case, what we're really doing is setting up a matrix that looks like this. 5, -2, 4, -2, 1, 2. And we're going to go ahead and solve this using our calculator. So all I need to do is remember these numbers. 5, -2, 4, -2, 1, 2. I'm going to have to go in and make the matrix, so I won't get any help from Neo. I needed to edit instead, I apologize, so I need to go second matrix. I need to go to edit, and we'll choose matrix B. And in this case, it had 2 rows and 3 columns, right? That's what it looks like over here. We had 2 rows, 3 columns, 5, -2, 4, -2, 1, 2. Is -1, right? And 2. Is that correct? 2 positive 1, 2. Bad. So I need to change that to 1. And enter, and there we go. Now we're ready to go. So now our matrix B has been set up. We will go to, we'll quit this, right? And then we'll be in our calculator page. We'll hit second matrix. We're going to go to math. And we want it to be in reduced row echelon form. So we'll hit that. And we have to choose the matrix that we're going to put in reduced row echelon form by going again to matrix and choosing B. Close the parenthesis. And there it is in reduced row echelon form. So we have some fractions as answers. We could put them back into fraction form, right? Get them away from decimal form. But what we have here is that x was equal to 0.889 and y is equal to 0.222. Okay. So x is equal to 0.889 and y equal to 0.222. Okay, so I made a mistake. We didn't point out this was supposed to be a negative 2. So let's recalculate. Can actually go up. And redo it, and there we go. Okay, so we got the solutions 8 and 18. Those are nicer answers. I like that much better. 8 and 18. So x equals 8. Y equals 18. Much better. All right, cool. Let's take it up a notch. Let's do a 3 by 3 system. So let's enter the world of 3 variables. And we are going to come back to that. Okay. So we'll come back to the word problem. I want to get us through actually looking at matrices first. So what we're going to do is we're going to create a matrix out of this, right? Luckily, all of our x's are lined up, all of our y's are lined up, and our z's are lined up. And just real quick, what we're doing here I don't know if you can see this. But imagine, if you will, that this is my y-axis, this is my x-axis, and that is my z-axis. Okay? So what we've done is we've taken the xy plane and we've set it flat on your table. Imagine you take your xy plane and you set it flat on your table. The z-axis is coming straight out from the origin. Okay? So this allows us to do math in 3 dimensions. So we've been doing math in 2 dimensions up to this point. What we're doing now is math in 3 dimensions. So you could actually, and this is really common that you would do math in 3 dimensions because that's where we live. Right? We live in a 3-dimensional. That's what our experience is. Our experience is 3 dimensional. You could get very philosophical with that. We're not going to do it. So anyways, does that make sense? Right, my xy, this is what it looks like. Xy is now laying flat, and z is coming out through the middle. All right? So just to tell you what kind of weird stuff we're dealing with. So here we go. So this, if I make a matrix for this, I'll have my x, my y, my z, and then my constant value. And then I'll put my x, y, z, constant value, x, y, z, and there we go. So we're now going to have a 3 by 4 matrix. And don't be confused. This is actually called a 3 by 3 system. And the reason why is because there are 3 variables and 3 unknowns. So that's why it's called a 3 by 3 system. 3 variables, 3 unknowns. Even though the matrix that we'll put in our calculators will be a 3 by 4 matrix. So let's go ahead and solve this thing. I'll need you guys to read these numbers off to me so I don't have to memorize. So let's go ahead and go to second matrix. We're going to edit, and we're going to make a new matrix, matrix C. And it is 3 by 4. All right, will you read these off to me?
Yeah. So it's 2, 3, negative 1, 5. And the next row is 4, negative 1, negative 1, and then negative 1. And the final row is 1, positive. Positive 4, positive 1, positive 12.
All right, and now we have our matrix set up. We'll go ahead and quit out to our calculator screen. And we'll choose reduce row echelon form. You can actually copy it back in there. And then delete this stuff. And we can find our correct matrix in there by going second matrix, and we'll just name matrix C. Close the parentheses. And hit enter. And there it is. It's in reduced row echelon form. So what this says is that x equals 1, y equals 2, and z equals 3. Okay? Now, we actually write this as what's called an ordered triple, the solution to this, right? So we got that x equals, what was it again? 1, y equals 2, and z equals 3. And we actually express our answers to 3 by 3 systems as an ordered triple, where this is x, y, and z. Because actually what we're finding, because what's really happening is over here in this thing, there are 3 lines in 3 dimensions. And what we have found is the point where these 3 lines cross. The point where the 3 lines intersect. Kind of interesting. So moving on to another example, we'll just go ahead and do this. But now, alright, so we have a typo here. This should be 2x, which means that we have the matrix 1, 2. What's that? What are you doing? Oh my God. Oh, Professor. Oh, Professor. What? Don't push 8. I'll do this one. Look at this, I love matrix. It's the best thing ever. Your teacher, Mr. Dorman, he is not that good. He's not knowing matrices. Look, our handwriting is exactly the same. It's amazing. So here we go. We put this matrix into a calculator because obviously Mr. Dorman is baby and does not want to put in reduced row echelon form by using matrix operations. I don't know why. He is soft. He has fear living deep inside of his heart. It creates a blackness. So we can go ahead and put this into a calculator. We'll go to second matrix. Oh, he has all of these here, and I will take matrix B. Oh, I've made. Never mind. I don't make mistakes. I want to edit matrix D. Here we go. This one is 3 by 4. Please recite for me numbers, because even though my memory is amazing and I could do it, I want to hear your voice. You say -3? I cannot understand your American accent. -1. 8. This is sometimes you say boobity boobity boo. 0. 1. 1,
4,
4,
1,
1,
negative 1,
negative 1,
negative 1, 2.
and 2. Look at this. My Russian brain is so far superior to yours, so I've done this well. So now I'll go out of my calculator and I will go to, I'll copy this reduced row echelon form, and I will make this, I'll delete it, and I will put for instead a matrix named of D for, not for Dorman, because he's okay, but he's not that good. So, D is for domination of USSR. And I would like it to be in a reduced row echelon form, and here it is. This says to me that y is 6, that x is 6, y is 2, and z is 2. Good answer here, because we are better than everyone. X is 2, y is
6.
I am testing your small American brain. That is good. I'm glad that you are better. Not than me, but you are better.
Should you just like all numbers? Yeah, it's S and U.
I should indeed use R, S, and U. Again, I test you. You're fast. R, S, U. And we leave like this because we don't want to put X, Y, and Z because this is specifically referring to coordinates within three-dimensional plane, three-dimensional space. Plane is Y. Excellent. You wait for a second. Thanks for watching is all. We're not going to do word problems like this because your American brain is feeble. And so thank you for watching Greatness, and long live Mother Russia.
Long live Mother.
Hey, do not mock my country. We have oil.
We have oil.